So, we're finally here. Kennedy Space Center. And yeah, I was pretty excited about this. Probably more excited than the average person should be about walking into a space center, but we'll just go with it. This is one of the newer areas of Kennedy, and one of the things that's really interesting about this place is that Kennedy isn't just where rockets launch. A lot of the actual integration happens here, too. The major components are manufactured and shipped in from different facilities, and then they're brought here and assembled, integrated, tested, and prepared for launch. Which makes a lot of sense when you think about the logistics behind something like this. You're basically taking pieces of a vehicle that were built in different places, bringing them together, and somehow making sure that when everything is connected, the whole thing works exactly the way it's supposed to. No pressure. And obviously, the giant building behind me is kind of hard to miss. The vehicle assembly building is where these vehicles come together before making their way out toward the launch complex. And the scale of this place is honestly ridiculous. You can look at it in a picture and think, yeah, that's a big building. Then you stand next to it and realize that, no, this is basically a warehouse designed for rockets, which is a pretty good sentence if you ask me. Once the vehicle is ready to make its way to the launch pad, this is where the crawler transporter comes in. The crawler picks up the mobile launch platform and the vehicle and slowly moves the entire thing down this route toward the pad. And when I say slowly, I mean very slowly. We're talking a few miles per hour. But considering what it's carrying, I think we can forgive it for taking its time. And this part is honestly one of the coolest things about being here. Because I'm standing here looking at a road that looks like, well, a road. But this is part of the same route that carried the Saturn V toward the launch pads during Apollo. The Space Shuttle made this journey too. So you're standing there looking at the exact landscape where these enormous vehicles were transported decades ago. And that's when something that normally just feels like history suddenly feels a lot more real. You're looking at the same roads, the same general area, the same coastline, and thinking about a Saturn V slowly making its way toward the pad. Then the shuttle. And now modern launch vehicles are doing essentially the same thing. It's kind of weird to realize that some of the biggest moments in spaceflight history happened in a place that, from ground level, can look surprisingly normal. It's just roads, buildings, trees, and a whole lot of Florida. But then you remember what has traveled across those roads. And suddenly the gravel has a little more significance. And then you look over here, and you've got SpaceX, which is probably the best possible reminder that Kennedy isn't just a museum for what we've already done. It's still very much an active spaceport. SpaceX continues to launch Falcon 9 and Falcon Heavy missions from the Cape, while also developing and expanding its Starship operations in Florida. So in basically one view, you can see decades of American spaceflight history, and the infrastructure being built for the next generation of it. And that's probably my favorite thing about Kennedy. You're surrounded by the history of Apollo and the Space Shuttle, but you're also watching the next chapter being built right in front of you. And somewhere in the middle of all of that, there's me. A business administration girl currently working on a master's in space operations, standing around taking pictures of roads, because apparently that's what happens when you get really into spaceflight. And honestly, I'm completely okay with it. I don't know if refreshing is the right word for a space museum, but after walking around outside for a while, getting into this building and being surrounded by all of this history is just really cool. Before we get to the Saturn V, they take us through the story of Apollo 8. And Apollo 8 is one of those missions that I think gets overshadowed a little bit by Apollo 11. Apollo 11 gets all the attention because, obviously, they landed on the moon. But Apollo 8 was the mission that first sent humans out of Earth orbit and all the way to the moon. And that was a pretty big deal. Apollo 8 launched on December 21, 1968, from right here at Kennedy Space Center. And the timing is pretty interesting because this was right in the middle of the space race. The United States had been working toward getting humans to the moon, and suddenly Apollo 8 became the first crewed mission to actually make the trip. Frank Borman, James Lovell, and William Anders were sitting on top of a Saturn V, and their destination was the moon. And, of course, none of that would have been possible without this thing. The Saturn V. This rocket was absolutely massive. It stood about 363 feet tall, weighed millions of pounds when fully fueled, and used 5 F-1 engines in its first stage. And those 5 engines produced roughly 7.5 million pounds of thrust at liftoff, which is a completely ridiculous number. And somehow, that was the solution they came up with for getting people to the moon. The Saturn V used 3 stages to get Apollo where it needed to go. The first stage did the heavy lifting to get the vehicle off the ground and through the early part of the flight. Then the second stage continued accelerating the spacecraft. And the third stage was responsible for putting Apollo on its trajectory toward the moon. That third stage would later perform the translunar injection burn that actually sent the spacecraft out of Earth orbit, which is one of those things that sounds pretty simple when you say it quickly, but is absolutely insane when you stop and think about it. Apollo 8 then traveled roughly 240,000 miles to the moon. Once they arrived, they entered lunar orbit and made 10 trips around the moon before firing the engines again to begin the journey home. And they did all of this without ever landing. That was intentional. Apollo 8 was about proving that humans could actually make the trip to the moon, operate around the moon, and safely come back to Earth. And they did exactly that. But we can dive into that in another video. After the Apollo 8 presentation, you finally get to walk into the Saturn V room. And this is probably my favorite part of the entire complex. There's just something really nice about being in that room. It's vast, it's cool, and you've got this enormous piece of engineering stretched out in front of you. And this is a Saturn V. Not a model like the ones that sit on a desk. Not a picture. An actual-sized launch vehicle from the Apollo era. You can walk underneath it and see the different stages, the engines, the interstage structures, and all of the hardware that made the mission possible. And when you see the F-1 engines up close, the scale really starts to make sense. 5 of those engines were sitting at the bottom of this thing, burning liquid oxygen and RP-1, and producing enough thrust to get this entire vehicle off the ground. Then you've got the S-2 second stage, the SIVB third stage, and eventually the Apollo spacecraft sitting at the very top. Basically, thousands of tons of hardware, fuel, computers, guidance systems, life support equipment, and everything else that had to work together to send 3 people to the moon and bring them home. And that's what I really like about this part of Kennedy. You aren't just looking at a rocket. You're looking at the hardware behind an entire series of missions that completely changed what humans were capable of doing. And yeah, I could definitely spend a while in this room. And now we get to my favorite part of the entire Kennedy Space Center, the Space Shuttle, more specifically, Atlantis. And this is honestly a big reason why I'm here in the first place. The Space Shuttle was what originally got me interested in spaceflight. It's the thing that made me look at space and think, yeah, I want to do something with this. And somehow, years later, I'm standing here studying space operations and getting to see one of these things in person. So yeah. This one is a little special. This is Atlantis, the 4th operational space shuttle built. It flew 33 missions between 1985 and 2011, spent more than 300 days in space, and traveled more than 125 million miles. And unlike the Saturn V, which was essentially built to get Apollo to the moon, the shuttle was designed to be used over and over again. That was the whole idea. Launch it, go to space, come back, land like an airplane, refurbish it, and do it again. Which sounds completely normal until you remember that we're talking about a spacecraft. And one of the first things you notice when you get close to Atlantis is the heat shield. There are thousands of individual thermal protection tiles covering the orbiter, each one designed to protect the vehicle during atmospheric re-entry. The shuttle would come back through the atmosphere at around Mach 25, with temperatures outside reaching thousands of degrees. And then this thing would just land, like an airplane. That is still one of the coolest engineering decisions ever. You've got the wings, the cockpit, the payload bay, the three main engines in the back. And then you realize that this thing wasn't just carrying astronauts. It carried satellites. It carried scientific experiments. It helped build the International Space Station. And it was also responsible for deploying and servicing the Hubble Space Telescope, which is another thing I think gets lost when we talk about the shuttle. The shuttle program wasn't just about launching people into space. It became this incredibly versatile platform for doing things that would have been extremely difficult or impossible to do any other way. And then there's the Canadarm. This giant robotic arm was used to move payloads in and out of the cargo bay and became one of the defining pieces of the shuttle program. Again, a robot arm on a spacecraft. In the 1980s, apparently we were just doing whatever we wanted. And then you get to the back of Atlantis and see the three RS-25 engines. These engines powered the shuttle during ascent, burning liquid hydrogen and liquid oxygen and producing enormous amounts of thrust. And what's really cool is that the RS-25 didn't disappear with the shuttle. Versions of this engine are now part of NASA's Space Launch System. So even though the shuttle program ended in 2011, pieces of that technology are still flying. And that's probably what I like most about the shuttle. It sits right in this weird middle ground between history and the future. It was experimental, reusable, incredibly complicated, and sometimes terrifyingly ambitious. But it also became a workhorse. It flew for decades and helped build the infrastructure we're still using in space today. And for me personally, this is where the whole thing comes full circle. The space shuttle was the thing that originally made me want to pursue a career in space. Now I'm studying space operations, learning about the planning, coordination, management, and execution that goes into missions like these. I obviously have a very long way to go before I'm anywhere near working on something like this. But standing here and looking at Atlantis, it's pretty cool to think that the thing that started the dream is sitting right in front of me. So yeah, Apollo was incredible. The Saturn V is ridiculous. But the shuttle? That's my favorite. And honestly, I don't think that's changing anytime soon. And of course, before I leave, I had to mess around with the space shuttle simulators. I figured, how hard can landing a space shuttle really be? Turns out, very hard. You're basically flying a giant unpowered glider at ridiculous speeds and trying to put it on a runway with very little room for mistakes. So yeah, after getting humbled by the simulator, I think I'll leave the shuttle landings to the professionals. And with that, I think that's a pretty good place to end the day. I hope you enjoyed this video. Make sure to subscribe, like, and give me ideas on what I should do next.